Today we will discuss about what is Meraki, definitions of terms, Meraki Cloud Architecture, data center location and features, Meraki Datacenter Storage, cloud communication process, configuration container, secure device connectivity, Meraki dashboard and API, high availability architecture, data backup and recovery plan, network data and management data, server data segregation, network usage data retention, data privacy and security practice, PCI compliance, Meraki security, physical and operational internal security.
What is Meraki? It is centralized management service offered by the Meraki Cloud solution, enables users to securely manage all of their Meraki network devices in one convenient platform. Customers can manage their Meraki devices either through the Meraki dashboard web interface or APIs, enabling deployment, monitoring, and configuration. After initiating a configuration adjustment, the request is transmitted to the Meraki Cloud and subsequently relayed to the relevant devices.
Definition of terms, Meraki dashboard. An advanced web-based interface utilized for configuring Meraki devices and services, accessible via modern web browsers. Account. A unique identifier assigned to a Meraki user, granting access to and control over their associated Meraki organizations. It serves as the primary authentication mechanism for accessing the Meraki dashboard. Organization. A hierarchical structure within the Meraki dashboard, serving as a logical grouping for managing Meraki networks. It facilitates administrative control over network configurations and policies, and can be managed by multiple user accounts. Network. A virtual grouping mechanism within an organization, designed to contain and manage a collection of Meraki devices and services. Networks enable centralized management and configuration of devices, facilitating efficient network administration. Management data. Information comprising configuration settings, performance statistics, and monitoring data generated by Meraki devices. It securely traverses from devices to the Meraki cloud via the Internet, facilitating centralized management and analytics. User data. Data related to user activities and traffic, such as web browsing and internal applications. Unlike management data, user data does not pass through the Meraki cloud, but is routed directly to its destination on the LAN or across the WAN.
Meraki Cloud Architecture. The Meraki Cloud serves as the foundation of Meraki's management infrastructure, encompassing a network of robust multi-tenant servers strategically positioned across Meraki's global data centers. These servers, functioning as high-capacity hosting platforms, accommodate numerous individual user accounts. Referred to as multi-tenant servers, they allocate computing resources among multiple accounts, ensuring efficient resource utilization. Despite resource sharing, Meraki prioritizes customer data security by implementing strict access controls. Organization access is carefully regulated through account authentication mechanisms, while sensitive authentication details like user passwords and API keys undergo encryption to safeguard confidentiality.
Meraki data centers locations. Each geographic region, North and South America, Europe, Asia, China, Canada, is equipped with a pair of data centers for redundancy, ensuring failover capabilities. These data centers host the primary Meraki servers for endpoints in the respective regions. Customers choose their data hosting region upon account creation. For globally distributed networks, it's recommended to create separate organizations for each data storage region. Users can find their hosting region displayed at the bottom of Meraki dashboard pages when logged in.
Meraki Data Centers feature. Data replication. Customer management data is replicated in real time across independent same-region data centers and in automatic nightly archival backups hosted by in-region third-party cloud storage services. Service redundancy. Meraki services, including the dashboard and APIs, are replicated across multiple independent data centers for rapid failover during catastrophic data center failures. Global presence. Meraki data centers are distributed worldwide, ensuring high availability local data containment for data sovereignty and facilitating reliable cloud management communication. Certifications. Data centers hold certifications such as PCI, SAS 70 Type 2 SSAE, and ISO 27001, ensuring compliance with industry standards and regulations. Additional features: 99.99% uptime service level agreement, 24/7 automated failure detection, real-time replication of data between data centers. Sensitive data, such as passwords, is hashed on servers.
Meraki Datacenter Storage. Meraki data centers host active Meraki device configuration data and historical network usage data. These facilities accommodate several compute servers responsible for storing customers' management data. It's important to note that Meraki data centers do not retain customers' user data.
Meraki device-to-cloud communications. Meraki employs an event-driven RPC engine for device-to-cloud communication. Devices serve as the receiver, with the cloud initiating calls for data exchange and configuration updates. The cloud infrastructure takes the lead in initiating configurations, allowing execution prior to device online status or physical deployment. During cloud connectivity loss, typically due to local ISP or connection issues, Meraki hardware devices maintain operation using their last known configuration until cloud connectivity resumes.
Meraki communication process. Meraki's robust communication process ensures that devices remain seamlessly connected, updated, and responsive. By leveraging cloud-based management and analytics, Meraki empowers users to optimize network performance and make informed decisions. Offline connectivity. When a device loses connectivity, it persistently attempts to reconnect to the Meraki cloud. Configuration updates. Upon reconnecting, devices promptly receive the latest configuration settings from the Meraki cloud. Any alterations made to device configurations while online are automatically synchronized. Configuration changes. Immediate updates are generally available within seconds. However, extensive modifications may require additional time for propagation. Automated configuration checks. In the absence of user-initiated configuration adjustments, devices autonomously monitor for configuration updates at regular intervals. Analytics reporting. Devices continuously relay device and network usage analytics to the Meraki cloud. These analytics facilitate comprehensive dashboard analytics, offering users valuable insights via intuitive graphs and charts.
Meraki configuration containers. Meraki configuration containers serve as a pivotal component in the management of device configurations within the Meraki cloud ecosystem. Here's an overview. Storage and updates. Device configurations are encapsulated within containers and stored in the Meraki backend. Modifications made by account administrators through the dashboard or API prompt updates to these containers. Propagation process. Upon configuration alteration, the updated container is securely transmitted to the associated device over a secure connection. Simultaneously, the Meraki cloud is synchronized with the new configuration to ensure consistency and reliability across the network. Failover and redundancy. The container's update mechanism is designed to support failover and redundancy protocols. By updating the Meraki cloud with configuration changes, redundancy is enforced to maintain network stability.
Secure device connectivity. Meraki provides secure device connectivity to the cloud through a proprietary lightweight encrypted tunnel, ensuring data confidentiality and integrity. Encryption. AES 256 encryption is employed to safeguard management data during transit, enhancing security. Tunnel security. HTTPS and protocol buffers are utilized within the tunnel, further fortifying the security posture. Bandwidth management. The solution intelligently manages bandwidth, allocating 1 kbps per device when not actively managed, ensuring efficient utilization. Benefits. Enhanced security measures mitigate the risk of unauthorized access or data breaches. Bandwidth management optimizes resource allocation, promoting network efficiency.
Meraki dashboard. The Meraki dashboard is a modern, browser-based tool designed for configuring and managing Meraki devices and services. Here's a concise overview. Web-based interface. The dashboard offers a user-friendly, visual interface accessible via web browsers, providing an intuitive alternative to traditional command line interfaces. Centralized management. It consolidates all Meraki devices within a network into a single platform, streamlining the configuration and management process for routers, switches, and security devices. Simplified configuration. Users can easily apply changes to their network configurations through the dashboard's straightforward interface, eliminating the need for complex command line commands. Comprehensive functionality. In addition to device management, the dashboard serves as a comprehensive platform for viewing network analytics for performance monitoring, applying network permissions and security settings, tracking user activity and device usage, streaming camera feeds for surveillance purposes, managing users' mobile devices and computers, implementing content rules and policies for web filtering, monitoring upstream connections for network reliability. Benefits. The Meraki dashboard enhances efficiency by centralizing management tasks, providing visibility and control over network operations, and offering a simple yet powerful solution for network administrators. Overall, the Meraki dashboard is a versatile tool that empowers users to configure, monitor, and manage their Meraki network infrastructure effectively from a single, user-friendly interface.
What is Meraki API? Meraki APIs offer programmable control over Meraki solutions, enabling actions beyond the capabilities of the dashboard interface, allowing for more precise management. These APIs adhere to RESTful principles, utilizing HTTPS for secure communication and JSON for object serialization. Open API accessibility empowers users to leverage cloud platform capabilities extensively, leading to the development of efficient solutions. Meraki APIs facilitate various functionalities such as automating deployments, network monitoring, and developing custom solutions atop the Meraki dashboard. API keys, specific to user accounts, are utilized for authentication and authorization. Users with administrative access to multiple Meraki organizations can use a single API key to manage those organizations.
Meraki's reliability and availability architecture. Meraki implements a high availability (HA) architecture to maintain consistent service for customers. Network connections via Meraki's data centers offer high bandwidth and resilience. Shared HA structures ensure data accessibility during localized failures. A robust data center backup architecture ensures continuous availability of customer management data even in catastrophic failure scenarios. Backups are securely stored on third-party cloud-based storage services. These third-party services organize Meraki data storage based on regional regulations for compliance.
High availability in Meraki Cloud Architecture. In Meraki's cloud architecture, both data center uplink connections and server availability are crucial for maintaining uninterrupted network operations. Here's how Meraki achieves high availability. Data center uplink connection high availability. Meraki utilizes multiple high-speed connections from its data centers to constantly monitor connection integrity. Continuous tests for DNS reachability assess connection integrity, enabling swift detection of degraded links. In case of a connection failure or degradation, Meraki seamlessly fails over to secondary links, ensuring uninterrupted network connectivity. Meraki server high availability. Each device maintains connections with multiple Meraki servers simultaneously. This redundant server connection ensures that all data remains up to date, ready for failover if needed. In the event of a server failure or connection loss, node connectivity seamlessly switches to the secondary server. Upon primary server recovery, the connection is re-established without impacting connected nodes. Meraki's robust architecture guarantees high availability, minimizing downtime, and ensuring uninterrupted network services for users.
Data center backup high availability. Meraki ensures robust data center backup and high availability to safeguard customer management data and ensure uninterrupted services. Primary and secondary data centers. Meraki maintains active customer management data in both primary and secondary data centers within the same region. These data centers are strategically geographically separated to mitigate the risk of simultaneous outages due to physical disasters. Real-time data sync. Data stored in the primary and secondary data centers are continuously synchronized in real time. This ensures that both data centers have identical, up-to-date configurations. Failover mechanism. In the event of a data center failure, Meraki employs an automatic failover mechanism where the primary data center seamlessly switches to the secondary data center. This ensures minimal disruption to services with the most recent configuration stored.
Disaster recovery plan for Meraki. In ensuring the integrity and availability of customer management data and maintaining the reliability of dashboard and API services, Meraki has implemented a robust disaster recovery plan, DRP, with a focus on redundancy and swift data recovery processes. Here's an overview of the key elements. Data center redundancy. Meraki employs a paired data center strategy within the same region. In the event of a disaster impacting one data center, operations can seamlessly transition to the paired data center, ensuring minimal downtime. In-region data center backup. In case of a complete failure of a data center, backups stored in the paired data center can be swiftly activated, facilitating quick restoration of services. Third-party cloud backups. To further mitigate risks, nightly backups are conducted and stored in 2 different third-party cloud storage services. These services offer their own physical storage redundancies, enhancing data resilience. Meraki's disaster recovery plan ensures that even in the face of unforeseen disasters, data integrity remains intact, and services can be swiftly restored, safeguarding both customer data and service reliability.
Management data stored in the Meraki Cloud. The Meraki Cloud plays a pivotal role in managing network infrastructure efficiently. Here's an overview of the key management data stored securely in the Meraki Cloud. User records. Essential account details like email addresses and company names are stored, along with optional information such as usernames and addresses. All data is encrypted during transit, ensuring user privacy and security. Configuration data. Network settings and configurations set via the Meraki dashboard are stored in the cloud. This facilitates centralized management and easy accessibility for users to configure and monitor their networks. Analytics data. Meraki captures and analyzes client, traffic, and location analytics data, offering insights into network usage patterns. Visualization tools enable users to make informed decisions and optimize network performance. Customer uploaded assets. Custom floor plans and logos uploaded by customers enhance the user experience. These assets personalize the interface and cater to specific branding needs. By securely storing and leveraging these types of management data, the Meraki Cloud empowers organizations to streamline network management, gain valuable insights, and deliver tailored user experiences.
Server data segregation in Meraki systems. User data on Meraki servers undergoes rigorous segregation protocols to ensure security and privacy. Here's how Meraki accomplishes this. Authentication based on organization membership. Each user's account is authenticated based on their organization membership. This means that users only have access to information tied to the organizations they belong to. Organization administrators manage user access by adding them to their respective organizations. Users set their own usernames and secure passwords. Scoped data access. Once authenticated, users are tied to their organization's unique ID. They can only make requests to Meraki servers for data scoped to their authorized organization IDs. This ensures that users can only access information relevant to their roles within the organization. Development and production separation. Meraki's development teams maintain separate servers for development and production environments. Live customer data is never used for testing or development purposes. This segregation prevents unauthorized access to user data and ensures that any development changes do not impact live customer information. In conclusion, Meraki's stringent data segregation measures guarantee that user data remains secure, accessible only to authorized users within their respective organizations, and insulated from development activities.
Network and management data segregation. The Meraki network architecture employs robust segregation measures to ensure the separation of network and management data. Here's how it works. Out-of-band control plane. Meraki implements an out-of-band control plane which effectively separates management data from user data. This means that the control and management functions are handled separately from the user traffic. Flow of management data. Management data, which includes configurations, monitoring information, and device management commands, flows from Meraki devices such as access points, switches, and security appliances to the Meraki cloud. This transmission occurs over a secure internet connection, ensuring the confidentiality and integrity of the data. Flow of user data. On the other hand, user data, encompassing network traffic, web browsing, and internal applications, bypasses the Meraki cloud entirely. Instead, it flows directly to its destination on the local area network, LAN, or across the wide area network, WAN. This direct routing enhances performance and minimizes latency. By segregating network and management data, Meraki ensures efficient operations, enhanced security, and optimized performance for its users.
Network usage data retention practices by Meraki. Meraki, a leader in network management solutions, implements robust data retention policies to ensure the integrity and accessibility of critical information. Here's a breakdown of their approach. Data types stored. Meraki captures and retains various management data, including application usage metrics, configuration changes, and detailed event logs, all crucial for network monitoring and troubleshooting. Geographical data storage. Customer data is securely stored for differing durations based on geographical regions. In the EU, data is retained for 14 months, while elsewhere, it's stored for 26 months, aligning with global regulatory requirements and best practices. Retention period calculation. Meraki's retention periods are derived from year-over-year reporting cycles, set at 12-month intervals, supplemented by an additional 2 months to ensure data integrity during backup processes and deletion procedures. Database infrastructure. To facilitate efficient data management and retrieval, Meraki employs a proprietary database system. This system is optimized for scalability, performance, and ease of searchability, enabling swift access to historical network usage data. By adhering to these meticulous data retention practices, Meraki ensures that network administrators have access to comprehensive historical data, empowering them to make informed decisions and maintain optimal network performance.
Segregated user assets in Meraki Cloud Architecture. Meraki, a Cisco technology, employs a robust system for managing customer-uploaded assets while ensuring stringent security measures. Here's how it works. Asset storage. Meraki securely stores assets like custom floor plans and splash logos. Network segmentation. Uploaded assets are accessible only within the specific customer network, ensuring data isolation and confidentiality. User authentication. Access to these assets is restricted to authenticated users with appropriate permissions, linked to organization or network ID access. This segregation of user assets within the Meraki ecosystem ensures data privacy and security, mitigating the risk of unauthorized access or data breaches.
Data security practices in Meraki Cloud Architecture. Data security is paramount in any network infrastructure, and Meraki takes significant measures to ensure the protection of data transmitted and stored within its ecosystem. Here's an overview of the key security practices. Secure Communications Tunnel. All data exchanged between Meraki devices and servers travels through a proprietary communications tunnel. This tunnel ensures the confidentiality and integrity of communications by encrypting the data in transit. TLS encryption for client management connections. Client management connections, including those through the dashboard and API, utilize transport layer security, TLS encryption. This encryption ensures that all application traffic remains secure during transmission. AES 256 encrypted backups. Meraki implements AES 256 encryption for data backups, guaranteeing robust protection for stored data. Moreover, access to these backups is restricted, further enhancing data confidentiality and integrity. In conclusion, Meraki employs a multi-layered approach to data security, encompassing encryption protocols and restricted access controls to safeguard data both in transit and at rest.
Data privacy in cloud solutions. As businesses increasingly adopt cloud solutions for data storage and accessibility, ensuring data privacy becomes paramount. Meraki, a leading provider of cloud infrastructure, recognizes the criticality of data privacy and integrates it deeply into its services. Sensitive data handling. Meraki acknowledges the sensitivity of data stored in the cloud. Hence, its infrastructure is designed to prioritize data integrity and security. Compliance considerations. Different industries and regions have specific regulations regarding data protection. Meraki's flexible cloud infrastructure is equipped to adhere to these compliance rules, ensuring user data remains protected. Privacy by design. Meraki embeds privacy considerations into every stage of product development and implementation. From the initial design phase to the final product release, privacy remains a core focus. Feature-rich privacy solutions. Meraki offers a comprehensive suite of privacy-driven features to its global customer base. These features empower users to manage their privacy requirements effectively, aligning with their privacy initiatives. In conclusion, Meraki sets a high standard for data privacy in cloud solutions. By prioritizing privacy at every level of operation and providing robust privacy features, Meraki ensures that user data remains secure and compliant with relevant regulations.
PCI compliance with Meraki. Meraki offers a robust solution for maintaining PCI compliance, meeting the stringent requirements of Level 1 PCI audits. Here's how Meraki's rich security features contribute to creating and maintaining a secure environment. Comprehensive security features. Meraki provides a comprehensive set of security features that address all PCI data security standards. These features include encryption, intrusion detection and prevention, firewall capabilities, and more. Building a secure network. With Meraki, businesses can establish a secure network infrastructure, ensuring the confidentiality and integrity of sensitive data transmissions. Vulnerability management. Meraki aids in maintaining a robust vulnerability management program by offering tools for identifying, prioritizing, and addressing potential security weaknesses in the network. Access control measures. Implementing strong access control measures is crucial for PCI compliance. Meraki enables businesses to enforce granular access controls, restricting unauthorized access to sensitive data and resources. Network security monitoring. Meraki's monitoring capabilities allow businesses to continuously monitor network activity for any suspicious behavior or security breaches, enabling timely responses to potential threats. In conclusion, Meraki's comprehensive security solution facilitates PCI compliance by addressing key requirements such as network security, vulnerability management, access control, and monitoring. Physical and operational internal security. Meraki prioritizes user security through robust physical and operational internal security measures. Here's a breakdown of our approach. Operational security training. Mandatory security training ensures all employees understand their role in maintaining security. Information security awareness programs. Formal programs educate employees on security protocols. Compliance requirements. Employees and contractors adhere to Cisco's background check policy and Meraki's security policy, bolstering confidentiality. Remote access security. Access to servers is via IPsec VPN and SSH, with strict access control enforced by internal teams. Role-based access control. Role-based models govern access to cloud servers, databases, and code, coupled with two-factor authentication for heightened security. Physical security measures. Continuous monitoring via guard patrols and video surveillance secures access to data centers. Biometric readers and keycard systems enforce limited access, verified through PKI and two-factor authentication. By integrating both physical and operational security protocols, Meraki ensures comprehensive protection for its infrastructure and user data.
Thank you for watching and understanding.